Hydrogen is a game changer. It has the potential to transform the planet by supplying and storing green energy. It can be used to power trucks, ships, planes, and even cities. But in order to make the hydrogen revolution a reality, humanity must overcome several technical and economic challenges. So let's get ready to take a trip to the atomic level and see if hydrogen has what it takes to change the world. If you opened a book of the universe, you would find hydrogen in the very first chapter. That's because it's one of the building blocks of the universe. It makes up 90% of the atoms in the stars. And on Earth, hydrogen is one of the main components of water, plants, and even the DNA of all living things. It's also an extremely energetic fuel, which is why NASA uses it to power rockets for space exploration. Clearly, hydrogen is already taking humanity to new heights. And best of all, it doesn't produce any CO2. So why isn't it the top energy choice worldwide? Well, it's not that simple. Hydrogen is difficult to extract from Earth in its pure form, even though natural deposits exist. It's usually combined with other elements to form compounds. For example, when partnered with oxygen, it makes water, or H2O. It can also team up with carbon to make fossil gas, also known as methane or CH4. So in order to obtain pure hydrogen, it must be separated from whatever elements it's paired with. When hydrogen is taken from water, this releases oxygen. When it is separated from fossil gas, this releases carbon. So whether using hydrogen as a fuel is good or bad for the planet depends on how that hydrogen is produced. Currently, there are three main ways to produce hydrogen fuel, classified as grey, blue, and green. Today, most is made from fossil fuels, and the most common type is grey hydrogen, made from fossil gas. But whether you use gas, coal, or oil, producing hydrogen from fossil fuels releases a lot of CO2 into the atmosphere. And sadly, these forms account for over 99% of all hydrogen production. Ouch! In fact, production of grey hydrogen alone emits more CO2 than the United Kingdom and Australia combined. Now, in recent years, advances in technology known as carbon capture and storage have allowed power plants to catch their CO2 emissions and store them underground. When this is paired with hydrogen production, the result is called blue hydrogen. But while this method reduces CO2 emissions, it's currently prone to leaking methane, or CH4, which can be more than 80 times worse for the atmosphere over a 20-year period. One study even found that if done incorrectly, the increased CH4 emissions can be so high that it would be better to just burn fossil fuels in the first place. What scientists are really looking for, the El Dorado of clean energy, is called green hydrogen. This is produced from water in a chemical process known as electrolysis. So imagine a big tank of water, or H2O. In order to get the hydrogen, you first need to break its bonds with oxygen. To achieve that, you use electricity. The current is used to break apart the bonds in the water molecules, producing precious hydrogen gas. Simple. All of this can be powered by renewable energy like solar and wind with close to zero emissions. This green hydrogen has the potential to reshape the world. Industries like petrochemical production and steelmaking which account for around 3.6% and 7.2% of global emissions, are beginning to be cleaned up by using green hydrogen instead of fossil fuels. And some countries are investing in it to decarbonize the production of ammonia, a compound used in fertilizers, which would cut a further 1 to 2% of global emissions. Experts are investigating its use in the transportation system too. While cars are a low priority due to the proficiency of electric vehicles, long-distance trucks, international shipping, and long-range aircraft have a higher priority. Since they can't use heavy batteries for power, green hydrogen is an ideal alternative. And in theory, and as long as it's made sustainably, the only direct emission from using hydrogen fuel is water. In fact, this water is even used on NASA's space shuttles, where astronauts actually drink it. So what's the catch? Well, if you simply burn hydrogen, it can also cause nitrogen in the air to react and produce nitrous oxide, a polluting greenhouse gas. This is still cleaner than burning fossil fuels, but the cleanest option is to avoid burning it at all and use a hydrogen fuel cell, which directly converts hydrogen's chemical energy into electricity. Not only is this more efficient, but it produces zero nitrous oxide emissions and, of course, zero CO2. Sounds good, right? So why is less than 1% of the hydrogen produced today green? Why isn't everyone jumping on this eco-friendly version? Well, at the moment, hydrogen is expensive and requires a lot of electricity to produce. Put it this way, if you wanted to power your phone with green hydrogen instead of directly charging it with renewable energy, you would first need to convert electricity from renewable sources into hydrogen and then use a fuel cell to convert it back into electricity. Doing this could lose up to 70% of the energy you would have received if you'd directly charged your phone with solar panels in the first place. Looks like green hydrogen doesn't give you a lot of bang for your buck. So why should people use it to power their homes and cities? The answer lies in one of hydrogen's most powerful properties: its ability to store large amounts of energy for future use. Since wind turbines need wind and solar panels need sunlight, gas and coal often have to step in on dark and windless days to keep electricity up and running. But here's a greener idea. You power homes with renewable energy through a flexible smart grid and build enough wind and solar farms to generate an energy surplus. Excess power can then be funneled to green hydrogen plants where it is used to make hydrogen. This hydrogen can then be stored and used to generate electricity when solar and wind can't meet demand. And if that wasn't enough, hydrogen can be stored in vast quantities underground for long periods of time in old mines, salt caverns, or even depleted oil and gas reservoirs. So it can be used year-round, even in the cold winter months. This is called interseasonal storage, and many countries are already investing in it. One day, it could even help eliminate dependence on fossil fuels. Better yet, these huge hydrogen supplies give countries more energy independence, making them less reliant on energy imports, so they won't need to rely on other countries to keep the lights on. But couldn't batteries do the same thing? Not quite. The amount of batteries required to store weeks or months of reserve energy for a city would be way, way more expensive. Hydrogen, on the other hand, can be very cheap to store at scale and could solve this energy storage problem. So, could hydrogen play a role in decarbonizing the planet? Well, only if it's green hydrogen made from renewables and only if the cost is realistic. To make that happen requires expanding and updating infrastructure and deploying renewable energy at scale. But there's good news. Wind and solar power are now cheaper than fossil fuels, and thanks to recent technological advancements in electrolyzers, the price of green hydrogen production is also rapidly decreasing. So, provided we support this emerging technology, green hydrogen could be one of the shining stars we've been waiting for. Please spread the word about climate change solutions by sharing this video, and like and subscribe if you would like to see more. Thank you.